So today we're talking about modeling chemical formulas, and we're going to see how these chemical formulas can give us some information that will let us kind of get a better picture of what these these compounds are made of. So before we start talking about real chemical formulas, I kind of want to give you some examples here. So let's look at this example formula here. Okay, so when we're talking about chemical formulas, what we know is that they give us information about what the compound is made of. So I've got this example here. This example, it tells us that there is one E, there's 4 D's, and then 4 T's. So what I want you to do is I want you to think about some object that's going to have 1 E, 4 D's, and 4 T's. Well, if you think about what the E could stand for, what the D's could stand for, and what the T's could stand for, you might think of a car. Okay, because a car is made up of 1 engine, 4 doors, and 4 tires. So this could be the chemical formula for a car, for example. So let's look at another one. So how about this one? Again, we've got 1 E and then 2 T's. Give up. That's a motorcycle. Okay, because a motorcycle has 1 engine and 2 tires. Now here's an easy one. Now that we should have this pattern going. 1 E, 2 D's, and 18 T's. You probably guessed that is a semi-truck or an 18-wheeler because it's made of 1 engine. It's got 1 engine, 2 doors, and 18 tires. So you can see how these, what are called subscripts, tell us information about how many of each one of these parts there are. So now that we've kind of talked about those subscripts, I want to go back to our car example here. And if we look at our car example, and if I put a 2 out in front of that, that says 2 of those cars. So that would mean there are 2 cars. So what we've kind of given you examples of here are the different parts of chemical formulas. So let's look at some notes here real quick. So a chemical formula is, well, a chemical formula is a combination of numbers and symbols that represent the amount and kind of elements in a compound. So this chemical formula tells us it actually tells us what the compound is made of. Okay, so again, it's made up of symbols, chemical symbols, and numbers that tell us this information. So the chemical symbols tell us the kind of elements, and those numbers tell us the amount of those elements. It tells us the amount of atoms of each element in that compound. So we've got chemical formulas tell us what the compound is made of. So now we're going to talk about what those numbers mean. So the first type of numbers that we're going to talk about are subscripts. So subscripts, they're a number to the right of the chemical symbol. Okay, so if we look at this example here of H2O, This subscript is a number to the right of a chemical symbol. So if we look at hydrogen here, there is a number right here that is to the right of that chemical symbol. So that 2 in this example is a subscript. It's also below the normal line of letters. If you look at this example again, it's below where that H sits in a line. So it's below the normal line of letters. And it shows how many atoms of that element are present. So this 2 tells us that there are 2 atoms of hydrogen. And then if we have no subscript, that means there's only 1 atom. So in this example, oxygen has no subscript there. So that tells us that there is 1 atom of oxygen. So again, no subscript means 1 atom. If there's a subscript, that tells us how many of that element are in the compound. So we're going to keep looking at this example of water here, so 2H2O, and we're going to talk about the number that's in front of it. So this coefficient. So this coefficient is right here. So a coefficient is a number written in front of a chemical formula to show how many molecules of the substance are present. So this number in front tells us that there are 2 molecules of H2O, or water. Then again, if there is no coefficient, that tells us there's only 1 molecule. So again, just like subscripts, if we don't see a coefficient, that tells us that there is 1 molecule of that compound. And there's one more thing that we'll occasionally see, and those are parentheses. So if we see parentheses in a compound or in a chemical formula, that tells us to multiply by either the coefficient or the subscripts in the case that there are any. Okay, so for example here, if I have magnesium, and then I've got a parentheses here, and inside that parentheses I have OH, and then I have a 2, it's telling me that there are 2 of these OHs. So that means there's 2 O's, means there's 2 H's. So you multiply it by the subscript here. Remember, these, they don't have a subscript, so that we would be multiplying 2 by 1. If this had a 2, we would multiply this 2 by that 2. So you multiply either by the coefficient or the subscripts. Then if there was a 2 out here, we would have to multiply this 2 by that 1 by that 2. But we'll get more into that in a little bit. So now let's go ahead and look at a model of H2O, so water here. So this would be kind of an example of this compound, what we could model it as. So in this formula up here, it says there's 2 hydrogens, which are represented by these blue circles here. and 1 oxygen. So that's going to be the larger part in the center there. So this chemical formula tells us that for every 2 hydrogen atoms, there is 1 oxygen atom. So for every 2 hydrogen, there is 1 oxygen. So again, we get all this information from the chemical formula. So we get the information of how to model it. We get information about how many atoms, what the ratio of the atoms are, and then how many of each type of atom there are. So now we're going to look at actually doing some models. So I've got my whiteboard here. We're going to start with this compound here. So C3H5O2. C3H5O2. So the first way I'm going to show you here is using some cutouts that I have. So it says that there are 3 C's. So I've got 3 carbons. And then it says there's 5 hydrogens and 2 oxygens. So I'm going to throw these oxygens on here. And then we'll throw the rest of the hydrogens on. So in this model, we've got all of these parts attached to one another. Okay, so this all is an example of a model for this compound. So there's 3 carbons, 5 H's, and 2 O's. 3 carbons, 5 hydrogens, and 2 oxygens. So this would be one type of example that we could use to model this compound. Now the next type of model that we could use is by actually drawing out the model. So we'll go back to this example here. So we've got magnesium, then we've got OH in parentheses and 2 around that, or 2 outside of that. So I'm going to start with 1 in the middle, and we're going to say this is magnesium here. We'll kind of give them some color. And then attached to that, it's saying there's 2 OHs. So I'm going to add over here an oxygen. And then attached to that, I'm going to do a hydrogen. And then over on this side, I'm going to do another oxygen. And attached to that, we'll do another hydrogen. So when I do a model like this, what I like to do is I like to go through and actually write the chemical symbols on there so I can make sure that I've got everything here. So we've got magnesium, we've got 2 oxygens, and 2 hydrogens. So if we look back at our chemical formula, 1 magnesium, we've got oxygen here. It's multiplied by 2, so we've got 2, and then 2 hydrogens. Now the last type of model that we're going to do is I'm going to show you how to use some popped cubes, and then this is what you're going to do to practice modeling next. So we're going to look at this chemical formula right here. So we've got to look and see what all information this chemical formula tells us. So we've got to look at, well, let's look at the coefficients first. Okay, if we look at the coefficient first, that tells us there's 3 of these SO4s. So we need to model this SO4, and then we have to repeat it 3 times. So we're going to start with 1 SO4 here. So sulfur, it says there's 1 sulfur, but it's inside parentheses. So that tells us we have to multiply this 4 by that 1 that we assume is there. So we've got 1, 2, 3, and 4. If we go ahead and connect those, we've got our 4 sulfurs. Then we look at oxygen here. It says there's 4 times that 1 again. So we're going to add 4 more oxygens to this model. And then we're going to see that we've got 1 of those molecules. Now we look back at the coefficient, it says we need 3. So we're going to do 3 more of those. And I'll do this in a faster speed here. And then we've got those 3 molecules. So you can see how this coefficient tells us that there's 3 molecules of this same type of compound. So what you will end up doing with all this information is you'll be able to figure out the number of elements, you'll be able to figure out the number of atoms, and you'll be able to figure out the number of molecules. So we're going to stop at that point. I'm going to let you model some of these on your own, and then from there we'll go into actually counting these atoms.